best now. Got the keys, we the best now. Hey.
Good day, good day, good day. Welcome to our YouTube channel. So if you're new here, please help us by subscribing to our YouTube channel, as that will help us a lot. And to those that are returning to this channel, wow, I'm really grateful. I just realized that we are on 800 subscribers. That calls for a round of applause. I'm really grateful. I'm really thankful to you. So today we are on isomers. We are just going to talk about what are isomers and examples of isomers. Let's just get straight into it. So what are isomers? So isomers are described as two or more compounds with the same molecular formula but different structural formula, right? So the molecular formula, it is the same but actually different structural formula, right? So don't forget that the molecular formula just shows us how many of each atoms are in the molecule, right? How many of each atoms are in the molecule, while the structural formula shows us exactly where those atoms are situated, right? So it means that these molecules, we have the same of this, but how to draw that, they will be different. So just remember that if the structural formula is different, it will mean that also their names will be different. Also their names will be different. So if you're having different structure, also the name becomes different. So now let's explore more about these isomers, because we have different types of isomers. So we have chain isomers. So we're going to be talking about chain isomers, and also position isomers, and lastly functional group isomers. But this is actually simple. I'll explain this step by step. It's very simple. So let's start with chain isomers. So chain isomers happens when a straight chain changes to B. So this straight chain changes to have branches. That's how these chain isomers happen. Basically, that's what happens, right? When the straight chain changes to B, to have branches. So I'll draw a couple of examples here and we just go through over them, right? For an example, we can have this molecule here, this compound here. So this compound, as you can see, this is butane, right? This is butane. So butane is C4H10, right? So if one of these carbon can be removed here and be placed there, right? So now it becomes a branch. So now it means that we are going to have something like this. And when that happens, we know that the name of this molecule becomes different from what we're having there as butane, right? So the name of this now becomes, it's coming on carbon number 2. So this is 2-methyl propane. But take a look at something now that's interesting. So as you can see here, the molecular formula of this, it is C4H10. Let's take a look at that. So this is also C4. So this is also C4 and H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and also H10. So these molecules, they are having the same molecular formula but different structural formula. So this is butane, but different structural formula. The structure of this and the structure of this are now different. Hence, also the names will become different. The names also will become different. So when that happens, we call them isomers. But just because a straight chain is changed into having a branch, now we call them chain isomers. Maybe you can take a look at some other examples. So it means that C4H10 is only 2 isomers, this and that. It is having butane and it is having 2-methyl propane. So maybe let's try with pentane. Let's see what happens with pentane. So let's try with this pentane. So as you can see, pentane, it's like that. It is having 1, 2, 3, 4, 5 carbons. So it's C5H12. Let's see what happens if we remove this and place it there to make a branch. It means that this now becomes C, 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 and a branch there. And remember, the name is still the same. It is, the molecular formula is still the same. It is still C5H12. So this is still C5H12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Still H12. But now, what is the name of this molecule now? It is no longer a pentane. The name of this now, it is 2-methyl butane. It is now different. 2-methyl butane. So these are chain isomers. The molecular formula is the same. The structural formula is now different. And also the names become different. But also this, we can make another one. We can remove this and also place it there. So now this becomes something like that. So let's take a look at this. So still it is 1, 2, 3, 4, 5. So still it is C5 and 12H. So still it is C5H12. But the structure is now different. Can you see the structure now? It is now different. So what is the name of this molecule now? So the name, obviously, 1, 2, 3. So on carbon number 2, we are having a dimethyl. So this will be 2, 2 dimethyl propane. Dimethyl propane, like that. So these three, they are isomers. These three becomes isomers, like that. So the more the chain increase, the more the isomers of that molecule, right? The more the isomers of that molecular formula. As you saw that when we're having C4H10, we're having only 2 isomers. But now with C5H12, we're having 3 isomers of this molecule. So it means that if we increase to C6H14, we have more isomers, like that. But always just remember that chain isomers happens when a straight chain changes to have branches, or when a branched chain changes to have more of the branches as well. So this is more about changing from the chain to branches, like that. So these are chain isomers. Let's move to position isomers. So positioning isomers. So now with position isomers, it kinda a bit different, but still we are applying the same rules. So still the molecular formula is the same. But the structural formula is different, right? But the structure is different. But how different now? So now what happens is that on position isomers, the parent name or the parent chain remains the same. So the parent chain remains the same, right? So if it is propane, it is remaining propane. The parent chain is remaining the same. So the longest carbon chain, it is still the same. Remember, on chain isomers, the parent chain was changing from being a pentane to being a butane. So from 5 carbons in the chain to 4 carbons. But now in positioning isomers, this parent chain is remaining the same now, right? But what is happening now? Now the functional group is the one that is changing, moving around the parent chain. The functional group is the one that is moving around. For an example, I can have something like this. So maybe I have the alcohol there. So according to this molecule is still having how many carbons? This is still having 5 carbons. And also it is having how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus this one that is having the H like that, right? So still the same name like that. But what is the name of this now? The name of this, it is pentan 2 all, right? Because this functional group is on carbon number 2. But can you notice what can happen with this? This can move there, it can also move there, right? So we can also have something like this. We can also have something like this, just to show that this hydroxyl group is moved from carbon number 2 to carbon number 1, right? Or we can have this also move to carbon number 3 there. It can also move to carbon number 3. So when this situation like this happens, this is positioning isomers now. These are position isomers. So can you get what is happening here? The position of the functional group is the one that moved. So it moved from being carbon number 2 to carbon number 1 to carbon number 3. So also the names of these will become different. This is pentane 2 all. This will become pentane 1 all, and this one will become pentane 3 all. So these now are different, right? But check the parent chain. The parent chain is remaining the same with 5 carbon atoms. So now the carbon chain is not changed, just the functional group is moving around. So these we call them we call them position isomers. Position isomers. The position can be changing. So this can happen between the alkyl halides. It can happen between the alkenes. Like that double bond can move from carbon number 1 to carbon number 3, and so on. Or also the alkynes, that triple bond can move from carbon number 1 to carbon number 3 and so on, you see. But the basic information is that this parent chain is not changing, only the functional group is changing. It is moving around that parent chain. Those are position isomers. So now let's go to functional isomers. So functional isomers. Functional isomers are a bit similar to position isomers. But now what happens? On position, when we are moving the functional group around the chain, what happens is that sometimes when you move the functional group around the chain, just like you know that ketones, they're having something like this, right? Ketones are something like this with the double bond O, right? Like that, right? But now check what happens if we move this O to the end of the chain now. So this is a ketone, but when this O now moves to the end of the chain now, this now becomes a different type of molecule now. This is no longer a ketone now. This is now an aldehyde. So functional isomers happens between ketones and aldehyde because they are having the same functional group. So it means that when that functional group moves around the chain, if it's in between the carbon, like within the carbon long chain, it is a ketone. So this is a ketone. But when it moves at the end now of the chain, now it becomes an aldehyde. So that is the difference between the positioning isomer and the functional isomer. So the functional isomer is when now the functional group now changes, not really changes, but it becomes a different type of organic compound. So this can move from being a ketone to an aldehyde. And also notice that this functional isomer also happens between the esters and the carboxylic acid. Why is this like this? Because the esters and the carboxylic acid, they have kind of like the same functional group, right? That one that is having a double bond of O and H, right? So it means that when it moves to the end of the chain, it is a carboxylic acid, and when it is within the chain, it is an ester. And again, when it moves at the end of the chain, aldehyde, within the ketone. And also with the functional isomers, notice that the longest continuous chain, it is not changing. So also here, the longest continuous chain or the parent chain is remaining the same. Just the functional group is moving, but it moves to the point where it will change the name of the homologous series now. So this, when it is within, it's a ketone. At the end, aldehyde. Can you see that? Those are functional isomers. So I think I've explained everything about isomers, and I just hope you got this and you also enjoy it. So before you can exit the video, don't forget to subscribe, to like, and to share this video with your mates, right? So my name is Tifla. I'll see you on the next one. Have a lovely one.